Today we're on page 4 of our Chapter 7 notes packet, Section 7.3, which is fractional exponents. We have base x raised to the fractional exponent m over n. If n is a positive integer, then x raised to the m over n is equal to the nth root of x, all raised to the m power. It can also be written as the nth root of x to the m. Our main focus is going to be this way. The nth root of x raised to the m power. Note, if n, the index of the radical, is an even number, the base x cannot be negative. However, if n is an odd number, the base x can be negative. That's because if n is even, an imaginary number would result. For example, if we have negative 8 raised to the 1/3 power, well, this is equivalent to the cube root of negative 8. And the cube root of negative 8 is negative 2, which is a real number. However, if we have negative 16 raised to the 1/2 power, this is equivalent to the square root of negative 16, and we know that the square root of negative 16 is equivalent to 4i, which is an imaginary number. To evaluate an expression containing a fractional exponent, we're going to rewrite the expression in radical form. We'll evaluate the root and then evaluate the power. So we want to evaluate and or simplify without using a calculator. So this 25 to the 1/2, remember the denominator is the root, so this is equivalent to the square root. And when we write square root, we omit the index of 2. So this is equivalent to the square root of 25 raised to the first power. And the square root of 25 is 5. Number 2, 27x raised to the 1/3. This is equivalent to, this is the root, this is equivalent to the cube root of 27x. And we know that 27 is a perfect cube, we'll circle that, and out comes its cube root. And the cube root of 27 is 3, so that's 3, and the cube root of x remains. Okay. Before I go any further, let me just back up. In the space provided here, all right, let's just recall some of our powers. For example, like 2 squared, remember, is 4. 2 to the 3rd is 8. 2 to the 4th is 16. And 2 to the 5th is 32. 3 squared is 9. 3 to the 3rd, 27. 3 to the 4th, 81. And about 4 squared, 16, and 4 to the 3rd is 64. All right, that should be good. So keeping that in mind, now continuing with number 3. We have 16x raised to the negative 1/2. Well, take care of the negative exponent first by writing it as 1 over 16x raised to the positive 1/2. All right. So this is 1 over, again, this is the root, the denominator of a fractional exponent is our root. This is 1 over the square root of 16x. 16 is a perfect square. Out comes its square root, 1 over 4, and then the square root of x remains. Can we keep a radical in a denominator? Well, for good practice, let's rationalize the denominator by multiplying by the square root of x over square root of x. And our result is the square root of x over, remember, square root of x times square root of x is going to leave us with x. So the square root of x over 4x. Number 4, 125 raised to the negative 1/3. All right, take care of the negative first. This would be equivalent to 1 over 125 raised to the positive 1/3. 1 over 125 raised to the 1/3, that's equivalent to the cube root of 125, and the cube root of 125 is 5. So our answer is 1 over 5, or 1/5. Number 5, negative 125 raised to the 1/3. Again, the denominator is the root. So we're looking for the cube root of negative 125. That is a perfect cube. Cube root of negative 125 is negative 5. Number 6, take care of the negative. Write this as 1 over 81 to the positive 1/4. So this is 1 over exponent of 1/4 is equivalent to 4th root. So this is 1 over the 4th root of 81. The 4th root of 81 is 3. 1 over 3. Number 7, 27x raised to 2/3. Okay, so finally we have a fractional exponent in which our numerator is something other than 1. All right, so again, the denominator is still our root, so this is the cube root of 27x, and now our numerator of 2 means we raise that result to the second power. This is a perfect cube. Out comes its cube root, so that would be 3. Cube root of x remains, but now we have to raise this result to the second power and distribute here, so that's 3 squared, which is 9. Cube root of x squared. This is our answer. Right, distributing the 2. 16, or sorry, number 8. We have 16x raised to the 3/4. This is our root. So this is the 4th root of 16x, and then that result we will raise to the 3rd power. This is a perfect root. Okay, the 4th root of 16 is 2. So we have 2. 4th root of x remains, raising to the 3rd power. Distribute. 2 to the 3rd is 8. 4th root of x to the 1st raised to the 3rd is x to the 3rd. So 8, 4th root of x to the 3rd. Next, more practice. Negative 8 raised to the 2/3. This would be the cube root of negative 8. That result squared. Cube root of negative 8 is negative 2, and then negative 2 squared is 4. Number 10, 27x raised to the negative 2/3. Take care of the negative first by writing it as 1 over 27x raised to the positive 2/3. And this is 1 over cube root of 27x squared. Out comes the cube root of 27, which is 3. So this is 1 over 3 cube root of x. And we have to square that result. So this is equal to 1 over 9 cube root of x squared. All right, and I'm going to let us keep it with the radical in the denominator for this one because I am out of room. Right? But to rationalize that denominator, we would multiply by cube root of x over cube root of x. Number 11. We have 8/27 raised to the 2/3. Again, the denominator is the root, so this is the cube root of 8/27, and then to that result, we'll square it. These are both perfect cubes. The cube root of 8 is 2, the cube root of 27 is 3, and now square that result. And our answer is 4/9, 4/9. Number 12, take care of the negative exponent first. We have a fraction, so we invert the fraction, 27/8, raised to the positive 2/3 now. Again, the denominator is the root, so we're looking for the cube root of 27/8, and then that result we will square. Each is a perfect cube. 3/2 squared, 9/4. Number 13, we have x squared y to the 3rd raised to the 2/3. Okay, so this is our root. So we're looking for the cube root of x squared y to the 3rd, and then we are going to square that result. This is the only part that's a perfect cube. Out comes its cube root, y. Cube root of x squared, now squared. Distributing, we get y squared, cube root of x to the 4th. Oh, but now we can simplify this, right? Break x to the 4th down into x to the 3rd times x. And now x to the 3rd is a perfect cube. Out comes its cube root. So we have y squared x cube root of x. That's our answer. It would just be standard to write it alphabetical, meaning the x first. So x y squared cube root of x. But of course, the one before it is also acceptable. Number 14, 4x to the 1/2 y raised to the 3rd. Okay, so this isn't a fractional exponent, so let's see. Perhaps we should distribute here. All right, so 4 to the 3rd is 64. X to the 1/2 raised to the 3rd, you're multiplying, that'll be 3/2, and y to the 3rd. Okay, so we have 64. Y to the 3rd. Now the x to the 3/2, that means the square root of x raised to the 3rd. All right, and if I write it this way, let's simplify this. What part of x to the 3rd is a perfect square? Well, x squared is. Copy everything else down. We'll take out the square root of x squared, which is x. So we have 64 x y to the 3rd, square root of x remains. Next, we want to rewrite using rational exponents and simplify your answer. So writing using rational exponents, this is the root, so that's the denominator. So this would be equivalent to x to the 6/4. And let's just reduce. 6/4 reduces to 3/2. So this would be x to the 3/2. Our root here is square root, so that would be 2. So this would be 4 to the 1/2, a to the 1/2, b to the 6/2. Well, square root of 4 is 2. A to the 1/2, b to the 6/2. 6 divided by 2 is 3. So that would be 2, a to the 1/2, b to the 3rd. And the next one, so our root is 3, so our denominator is 3, right? So this would be 27 to the 1/3, x to the 6 over 3, y to the 12 over 3, z to the 1/3. Well, we know the cube root of 27 is 3. 6 divided by 3 is 2. 12 divided by 3 is 4. And z to the 1/3 remains. That cannot be reduced. So 3x squared y to the 4th, z to the 1/3. And lastly, we want to evaluate the 4 problems here. We want to evaluate f of 9 for number 1. So we'll replace our x's with 9's. Nine to the 3/2, right? This is the root, so that is the square root of 9 raised to the 3rd, and then the square root of 9. Square root of 9 is 2, and then we need to raise 2 to the 3rd power. That's 8. Square root of 9 is 3. Yes, I did that backwards. Sorry, caught myself at least. The square root of 9 is 3. Thank you. And then we want to raise 3 to the 3rd, and the square root of 9 is 3. Okay, so we have 3 to the 3rd, which is 27, plus 3, which is 30. Next, evaluating f of 8. Replacing our x's with 8. We have 4 times 8 to the 2/3 minus 8. These lights. Okay, got the lights back on. Try to get rid of the shadow. Minus 8 times, or excuse me, minus 8 raised to the 4/3. Here we go. Okay, so this is 4 times the cube root of 8 squared minus the cube root of 8 raised to the 4th. And the cube root of 8 is 2. This is 4 times 2 squared minus 2 to the 4th. 2 squared is 4. 4 times 4 is 16. Minus 2 to the 4th is 16. 16 minus 16 is 0. F of 9. This is going to be 3 times 9 raised to the negative 1/3 plus 2 times 9 raised to the 0. Okay, so 3 times 9 is 27. Move this over to here. Let's have some room. So this is 27 raised to the negative 1/3 plus 9 to the 0 is 1 times 2 is 2. Okay. Take care of the negative exponent. Write this as 1 over 27 raised to the positive 1/3. And this is the cube root of 27. This would be 1 over the cube root of 27 plus 2. So this is the cube root of 27 is 3. 1/3 plus 2 is 7/3. It's either, you can write it as 2 and 1/3, or this is 7/3. And I'll stop there, leave you with number 4 to try. And this concludes tonight's video.